Hi, everyone. I'm going to make a quick video this week to walk you through these three assignments, Galaxy Genomics Part 1, 2, and 3. And I'll show you some tips and tricks that apply for this whole week of working in Galaxy. So the first thing I want to mention, and this is kind of new this year, is 8 of the 35 students in this class are in Europe. And if you're in Europe, instead of following my instructions to go to usegalaxy.org, I want you to go to usegalaxy.eu. I have used this website a lot. I first started using it when I went to a workshop in England, and it just will load for you a little bit faster than if you go to the US instance of Galaxy. Once you're in Galaxy and you're ready to get started on the training tutorial, you should be able to, save your history and make changes, but you will have to make sure that you're logged in. So a lot of times when people are new to this part of the course, they'll run into errors because they'll be able to load the website, but they won't be able to load a tool. And until you're logged in and you've confirmed your email address with the email that gets sent to you and you first set up the account, you won't be able to launch any applications. In this Galaxy Part 1 history for Galaxy Genomics, you're going to pull data not from your computer, right? So this is a little bit like the side loading that we did in R. We're able to get FASTA files by writing code in R. We're able to get other information, for different tutorials last week in R, either in Posit Cloud or in a computer. And now what we're going to do is we're going to do something similar. We're just going to launch that code through this website. So we're going to go to the application, open up tools, get data, and we're specifically going to load data from the UCSC table browser. When I click on this, it should open up as a new window, and it will have some default settings, and we're going to leave most of these the same. So the assignment when I first posted it this week didn't have the latest version of GenCode. We want the latest version. So you can just leave that as GenCode v47. That is different than the screenshot in the tutorial, but this is the one that we want to use. For region, this will auto-populate to whatever you've last used, so it probably won't come up with chromosome 22. It shows up like this for me because that's what I last looked up. You don't have to type the range of base pairs. You don't have to type the base pair range on here. You can just type the chromosome, and then that will limit what the report shows to just that chromosome. And we're picking chromosome 22 for a really practical reason. It's the smallest. And so we want to pick the smallest paired chromosome to be able to get the bed file and have it be something that we can run apps on pretty quickly. So we want the output format to be bed. You remember from the glossary assignment, what the FQ, that this was, just a text file. It's just a text file that lists the start and end of any genomic feature. And we're going to send the output to Galaxy. When I click Get Output, it's going to give me a couple more options. It's going to ask for what kind of bed record I want. So in this case, I want a whole gene. For the second part of this exercise, so for Galaxy Part 3, you could just click on exons here, coding exons, you can do those, or you can use an application within Galaxy to filter your gene list to be just exons. So I'm going to leave it as whole gene and then send the query to Galaxy. I won't actually do that because I've already done it, and I don't need to re-import the bed file. But then I'll follow the steps in the tutorial to filter the list to be forward and reverse. One thing you can do to check that this is working correctly is you want to make sure the forward and reverse that they're different numbers, right? So 3,900, 4,337, and that they add up to the total number of genes, 8,237, and they do. You'll look for overlapping forward genes, overlapping reverse genes, and then you'll concatenate those two lists together to get a list of overlapping genes. Once you have this, one way to view it is to click the Visualize tab, but that doesn't load in everyone's browser. So an alternative way to look at bed file information is to load a genome viewer. IGV is one of my favorite tools. There's actually an IGV Shiny app that can let you create your own IGV viewers. And if we have loaded this, we can easily save this to our computer and go to Tracks, Local File, read in the bed file, and I can zoom by drawing a rectangle with my mouse on any given part of this and see some of the genes that are overlapping. And so you get a nice view. You can see each of the ensemble transcripts that show up. And now I have a good idea of which genes on this section of the chromosome are overlapping. For the screenshot for part 2, I'll accept any view that has these black genes visible. So you could zoom out to all of chromosome 22. You could zoom in to a very small part of it. Whatever view you want to do, as long as it's somewhere on chromosome 22 and the black truck is visible, you'll get credit. Before you start part 3, there is a part of the tutorial that suggests saving all of these steps in part 1 as a workflow. Workflows are like a superpower on Galaxy. When you are able to have a couple of steps that you always do in a row, you can turn those into essentially one application. So rather than clicking and running step 1, step 2, step 3, you can run all of it at once. To save into a workflow, you are going to click on this pancake option, and you're going to extract workflow. So that will convert your history into essentially a single application. And then when you click on histories, I'm going to switch to my new history. You can run the workflow. So I'll put workflows here, just by clicking on the workflow constructed from the history part 1 by clicking on this button, Run Workflow. This will take a while to load. We're not asking the Galaxy server to run a single application. We're asking it to run 1, 2, 3, 4, 5 different apps. And so it puts you in a queue and it puts you in line. And it usually takes a couple hours before it will fully load. But I did this yesterday. It's fully loaded today. All the steps have turned green and it was able to run. So now when I look at these two things together, I can see a list of exons that overlap is much smaller than the list of genes that overlap, which makes a lot of sense. So that's the basics of how to navigate this 3-step assignment. You are going to be able to, after you've done this assignment, have a really good idea of how to launch individual tools, how to launch workflows. If you're trying to see with your workflows, what you've done, you can actually click on an individual workflow and you can get a little report. So the state will say new if it hasn't yet gotten to the front of the line, and it will say scheduled once it is running. So it's just a nice thing to know how to check, because one thing that is true with this free tool is that we do have to sort of wait for available time to be able to use those computational resources. If you have any questions, feel free to stop by, but hopefully this will help with Galaxy Genomics Part 1, 2, and 3.